All right, so I want to talk about probability and statistics, particularly relating to engineering, but also related to business. I want to give you some preference. I teach research design at a doctoral level in a business school, but I'm an engineer and I've taken a whole bunch of statistics courses. And frankly, I think a lot of statistics courses are taught wrong. We look at all of these sort of mathematics and equations and all those kind of things. And frankly, it's supposed to be a lot more simpler than that. I want you to sort of think about intuition. And instead of thinking of the sort of mathematics behind stuff, right, and going into all of those different equations, I want you to start thinking as if you were like in the fourth grade or fifth grade or something, some sort of area along that way, and you're discovering something for the first time. And what you're going to realize when you go and do something, and I want you to do this, this is an easy exercise for you to understand what we're doing, is go and pick something that you're curious about. And now, when you pick that thing that you're curious about, right? So maybe it's mud puddles, right? So what I want you to do is measure the width of mud puddles that are around you. And what you're going to see is that after some time, as you measure those and you add all of those up, right? So you keep measuring those and you get 30, 50 different mud puddles. You're not going to do this because you think I'm a kook. But, this is what I would do in order for you to understand this a little bit more intuitively. Once you're going to realize this, you're going to realize that, hey, there is going to be a moment at the long run that across all of the different mud puddles in your area, there's going to be sort of an average size of mud puddles. So how do you calculate that average, right? It should be pretty easy to calculate that average of what that of the mud puddles are. All you do is you add up all of the widths of the mud puddles, right? The diameters of the mud puddles. You add them all up, and then you divide by the number of mud puddles that are there. And that's it. This number is called the central tendency. And what you're going to see over time is that there is a central tendency where the mud puddles go towards that central tendency. And I want you to try this with all sorts of things. Most things will have a central tendency if you're just picking them at random, right? That's the important thing, is that it is an independent draw, right? What's called independent, and you're picking it at random. And over time, you're going to realize that most things sort of converge upon this central tendency. Now, the other thing that you're going to realize is that as you take more of those samples, right? Like you get more and more of those samples, and you start taking not just samples of mud puddles, of the diameter of mud puddles in your neighborhood, you start going to different areas. And you're going to realize that you're going to get more confidence in what is the average width of a mud puddle, right? Like you're going to get more confidence. That's what you're doing, right? And ultimately, this is the entire thing of statistics behind what you're doing is, first of all, you're trying to find that central tendency and where is the sort of average that you're going to, or mean. Sometimes they call it the mean of what you're actually going to. But then as well as what is the confidence that you actually have in that particular measure. And there's going to be all sorts of statistical equations and all of this kind of stuff. But ultimately, that's all you're trying to do. It's really, really simple. And what you're trying to do is, what is your confidence in that particular measure? And that's going to be measured by your standard deviation or your standard error of how likely that you're going to be getting to that point of getting to that average. So that standard error is going to get smaller and smaller and smaller and smaller and smaller as you get larger, more numbers of mud puddles. That's it. It's pretty simple, right? Like that's the basics of statistics, and that's what long time ago when they started doing this kind of stuff, they wanted to understand what is the basics of this, and it really was, let's just sample. With Fisher, I think he was a person sort of invented this kind of idea of things with this sort of experimental method and statistics, and as far as I know, I believe so. Maybe it's a longer history than that, actually. But that's he's one of the dominant people in this particular domain. And what we're looking at is the number of times that you actually get there is the number of times that you sort of calculate this particular thing, the more accurate you get. Now, there's different approaches that you could do, sort of Bayesian and frequentist approaches. So this is a frequentist approach. But the more that you just sample over time, you're going to get to a central tendency, right? And that central tendency gets more accurate over time. That's the entire basis. Once you get that figured out, everything else seems pretty easy, because everything else from that is just little adjustments. Well, how would I figure out what is the impact of this variable on that variable, right? So instead of measuring the diameter, just the diameter of mud puddles, you might want to go measure what is the surface tension of the water at this moment, right? Based on what is going on in that water or that liquid, right? So then you want to look at what is the relationship between the surface tension of that liquid and as well as the diameter of the water or the liquid that you're looking at, right? And so those things, that would be another adjustment. That's where you'd get into things like regression, for example. And you would start measuring the impact of one variable on another. And we're really simply saying there's a central tendency where these converge towards something. And then we want to get the confidence, or we want to measure how what is this the likelihood that we are actually going to approach this particular number, right? All of these terms are really, they seem kind of scary things, but really we're saying ultimately we don't know what it actually is, right? That's what we're saying. That's why we do the sort of statistical approach. It's probabilistic. We don't know what the answer is, but the more that we gather data, the more likely that we're going to have a confident answer on what it should be. Now, this is assuming that the answer is out there, that we can sort of converge upon a particular value, but that's generally what it is. And then the other thing that we look at often, all of statistics, the whole thing is just breaking apart all of these kind of little different assumptions and looking at different ways of how this actually works, right? So instead of saying, hey, wait a minute, we're assuming that we're having independent draws from this, right? So we're assuming that we are going and all the mud puddles are independent from each other and there's no reason for them to converge. Well, what if you had a sprinkler and then you sprayed out the sprinkler and the mud puddles were all converging about where you actually sprayed, right? And we know that that would actually be correlated together, right? And we make adjustments to do that, to figure out how are they actually correlated together and what should we actually do. And once you get that this is just like, oh, wait a minute, let's get my head back. And I took so many of these stupid courses and every time I was like, oh my gosh, I don't really get what they're talking about. But then I take my step back and I start thinking about like, oh, that's all they're doing is they're looking at what is the likelihood that you're going to converge upon this particular value. And then from there, what is the confidence that we're actually going to get to this particular value? And there's all sorts of things that you can get at, but that's the gist of it. And once you get that in your head, like go back to fourth grade. I'm telling you, go back to fourth grade, try to understand how you were thinking about it back then, and then go forward from there. And it's going to make a lot more sense to you. And it's actually going to be pretty easy. The equations start, it's not easy, but the equations start making sense once you start doing that. All right, that's the trick. All right, take care. Bye.